pick the active speaker and then amplifies them. I see. CS2A is two-way. I actually forgot what it is. Hmm? So I'm gonna
plug into the speaker.
Still, but my phone is still battery.
Oh, excellent. All right, excellent. That's fantastic. All right. Hey, Eric. I thought you dropped the class. Are you here? Did you drop the class?
No, but I haven't. Hello?
Oh, hang on. I got it. One sec, okay? All right. So I got to figure this out. Join. I haven't joined the meeting. Okay. All right. So can you all hear me now? Yeah, Eric, can you say something?
Yeah, I can hear you.
No, why is it that? Oh, by the way, now that I heard the sound there, I just. So in fact, I forgot. I really want to thank you all, for actually enrolling in this class. I'm doing that from time to time having fun because I really don't have to. There's many sources out there, and you can also do the Zoom thing, but it's actually fun to be here. And then Tom reminded me when he was dropping me off to say that what, Simon was really cool, and it was fantastic that he had to set up and everything was doing a lot of work. And to make sure that it was up and people were reading it. So thank you very much for that, okay? I still can't figure out have you been in this class before, probably sitting in this area, but not, maybe you should go back to the other configuration. I think it was more, maybe I'll switch to some of the class next quarter. But yeah, I think generally we have fun. So thank you very much, all of you guys, for enrolling in this class. And the other thing I wanted to say was I'm encouraging online students. Right. So here's something that you watch and let me know. Okay. So here's what I'm trying to do. I got to turn my camera on. Oh, there it is. Okay, I can actually sit down here and pretend that it is a class, which has both online and face-to-face students equally immersed. And I'm just here. And the only advantage you guys have is that I'm right here, and I can talk to you. And if I need to use a whiteboard, what I can do is I can just pin me. Actually, Bonnie used to just say, well, why didn't you use an iPad? So yeah, I did think about that, but I'm actually more comfortable using the whiteboard. And so yeah, if we need to, what we'll do is we'll just turn this laptop around. Okay, no, this monitor around so you can see the whiteboard, and I'll draw there. Why is it? This iPad. It's not just comfortable in drawing. This is a pain of having to lug it around because without the iPad yesterday or last week, we discovered I don't need to bring my laptop here anymore because I can just talk about what I know and use the whiteboard. And you guys whiteboard most of the time, right? So I just having that one thing to bring along is a bit of a pain, especially if you use your public classes and all.
Yeah, so this is that someone didn't mute in this room.
Oh, I see. And I should also sit there. I should also sit there. Okay. So please remind me to get the hell back. All right. Just tell me to go back because I shouldn't be walking around because I'm basically here and the audio should remain constant. Okay. The audio should remain constant. Everybody able to hear me? Yeah. Yeah. Okay. And you can see me too. And I think that's the max brightness. And I think that's how we did it in. At home is the maximum brightness of the screen is essentially enough for the illumination required for Zoom. It's I actually get much better luminosity with the Mac screen. I think even the small Mac screens, unless this guy is like terribly, is dim. But if you guys can see me, that's fine. Okay, so and that's great. Okay, all right, excellent. So here's what we'll do. Let me all of you guys switch on your cameras. We actually have a few new people that joined us today. Megan, Josh, okay, Dimitri, and a few more people. Oh my gosh, I was supposed to send ad codes out to a few people today, or Zoom links. Gee, okay. How do I get the Zoom links to at some point? I gotta excuse myself for like 5 minutes to email the Zoom link. You know what we should do? Right. Hey, you guys can see the screen. Oh, gee, the people that I need to email are not there. Okay, I'm going to take a screen photo, right? So here's what I'm going to do. That's the quickest thing. I'm just going to log out of Zoom for a second. Okay, so it's not going to take a lot of time. Log out of Zoom for a second. I'm going to get the photo of that thing, and then email it to the people so they can just get into the link. Is that okay? I think. Or just email it to them. No, I can't. Then I have to log into my email account here on this device. If someone knows a shortcut, let me know.
If you're only trying to email it to Dmitry and Tatiana Grinberg.
Oh, but then I have to email it to them somehow. Oh, that's okay. Tell it to me. All right. So how do I? So I go to the Zoom. All right, and then here it is. This is the one. Oh, I don't have to log out. Okay, here it is. So and then I can copy this. Can you guys see the screen? By the way, you can see the screen. Oh, I'm so sorry. But you can see it on the thing. On your own screens. Because it's Zoom, like I'm at home. Yeah, you don't have to see this. Technically, you don't have to. This is just a nicety. I'll switch it on at some point. So I can do it now. PC. All right. So I think it'll warm up. And so everybody should be able to see the screen. Is my screen shared? All right. Let me take a. All right, so this thing, copy that, and then I go to. Can you see the screen now? Why is it not? Is it warming up?
On the panel?
Oh, on the panel. Oh, on off. Oh, yeah. Thank you so much. Thank you so much. Yeah. elkey.com. I'll just say elkey. And I just need to send this to them. Well, I can't paste it. Okay. And what is it? So this is it. NOR. So I just need to tell them to go to this URL. I said that's a problem, but still I have to, when I go to the email. Yeah, and I don't think it's a pain. Even what if they log in after a half hour? I'm gonna apologize to them later. Okay, so they can watch the recording. They're not going to be able to join a meeting. There are a couple of people who wanted to join the class, and I said, "Come to today's class." I asked for the Zoom link, and I said, but I was on a bus at that time, and I said, as soon as I get to class, I'll send you the link. I promised them. And they seem really interested, but unfortunately I'm not able to send it to them. So sorry. Thank you for your patience. I was trying to do that. I'm going to let it go this time.
I think the two people you're trying to email were able to join actually.
Yeah, okay. All right, cool. All right, so we can just get into our meeting then.
Yes.
Where's our meeting gone? Where is our meeting? Where's the how do you do this on a PC? How do I find the meeting? This is it? Zoom? No, this is it. That's Mozilla. Oh, this is Zoom. Oh, I see. Windows. If you don't keep track of a couple of versions of the operating system, there's so many things that are new. So that is kind of cool. All right. Anyway, so in fact, we can even maximize the screen so it'll be much better. There it is. All right. Great. Okay. So we're in the middle of class. Hey, Kira, I didn't know you were going to be online today. Juliana actually told me. But where is Juliana? I don't see her. Dimitri, is that your wife? Your wife also wanted to join, yes? But you're using the same. Oh, you're using the same login, both of you.
Yes, we're using the same login.
Oh, I see. So your name is Tanya?
Yes.
Oh, great. Okay, yeah. Welcome to class. So we have a bunch of people. There's a couple more. Okay, there's a couple more, but I can let them know, and we're going to get everything recorded. Okay, so here's my plan for today. I'm just going to sit here. Okay, I'll resist my temptation to walk around. If I'm walking around class, just tell me to get the hell back. That's all you have to do, right? So this is a small favor I'm asking for you. So thank you. Yeah, all the way back up to on. All right, Jonah, good, right? So if I come and talk to you, even make small talk and chit chat, just say, let's talk after class. How about that? Is that okay with you guys? Right? So that means that I got to get back in front of the camera because if I'm talking out to you, all the online students, they're completely, and a lot of people are online. Even our face-to-face students are online, like Kira. Yeah, Kira, and our face-to-face students who said they were going to be online are not online. Okay, so I got to remind her. Roger, yeah, welcome to class. Yeah, all right, cool. All right, excellent. So here's my plan. what we're going to do is, and I had a completely different plan before, and Panini convinced me when it was dropping me off. At Fudo said, no, that's, let's just go through the demos. It'll be more fun. So I think it's a much better idea. So here's what we'll do. All right. So all of you. Oh, by the way, Panini is my son, and I convinced him he'll have a lot of fun in this class. He was my cloud student a long time ago, and then I told him, come to this class. It'll be fun. But he said no. And I said, try it out. You might actually like it. And I said, yeah, sure. It'll be fun. I'll come along for a few classes anyway. It'll be fun. And it's been a great help for me. So thank you very much, Panini. Okay. And he's helping with the tech too. So that's kind of cool. So what was I saying before? So yeah, a bunch of people who are not here in class today, they'll have an opportunity to join. But I think hopefully going forward, we'll actually have a streamlined way of doing things. We'll just jump into code and do things. So today I was planning to do something else. But if some of you have a good idea, like Panini told me today, even now, if someone says, hey, this sounds like something interesting that we can do, and if it's within the scope of things that we can do at that time, like right now, what do we know? We know loops. And then branching statements, and within that scope, we're a bunch of things we can play with, right? We can experiment. Maybe we'll say, I want to do some experiments now. Maybe someone says, I want to share my screen and do some experiments. And in the experiment, all you're going to try and do is do a loop with a plus plus. That's all, okay? And you just want to know what a plus plus does, right? While I plus plus, and then print the n at the end. And say while plus plus I or something like that, and see that experiment alone, I bet, right? If you don't gloss over it, and that is a super duper valuable nugget of knowledge that many people miss, okay? Because you spend a lot of time more on stuff that follows if you don't get this in your bones, okay? When the plus plus happens or the minus minus happens, okay? So that is something that you just have to practice. So if you already know how to do this, this would be a great opportunity. Even not here, when you start on your own. You say over a Sunday or something, over coffee, because, you don't have to put a whole lot of cycles to it. You can do some other stuff on the side and say, well, you know what, I'm going to just try different kinds of I++. And so that you don't have to dynamically remember all that, you can just say in your phone or something, you make a list. I think these are the different things I want to try, but, it's not worth finding up my computer for this one experiment. So just make a note of all these. The danger with saying that I'm going to sit down and remember all that is you never remember all that, okay? Because you get distracted. It's like looking for a meaning in a dictionary. I don't know if you've had this problem before, because when I was young, I never used to find the meaning of the word that I wanted in a dictionary, because I try to find the word, but I find something else that I'm interested in. And then that leads me down a rabbit hole, essentially. So, and after a half hour, I realized that, oh my gosh, that's what I wanted to. And I'm pretty sure this happens to lots of people, lots of times, and not just in a dictionary context. This kind of thing happens in different settings, in different places. We're just going down rabbit holes that are tantalizingly interesting and simple. So we just want to guard against that. So I don't know how we start talking about that, but essentially, hey, all of you should feel free to switch on your cameras. Roger, you too, right? So are you better now? You said you weren't feeling better. If you're feeling good last time.
I'm here.
Yeah. All right. Great. All right. Caesar too. Oh, you're in class?
Yes.
But I thought you were. Oh, you know what? Yeah, I just imagined that you were online because last class, yeah, you were absent, but you sent an email saying you're sick or something. Yeah. Okay. And then I saw you pop up here, and I thought, well, that's all online students. Hey, who's next to Caesar? Caesar. Well, he was. Yeah, Caesar, you're here too. You just joined. All right. So I was thinking both of you were. Jonah is here. Dimitri. Yeah. Dimitri and Josh Pion. He just joined today. Megan. Oh, there is another screen. All right. So here's the cool thing about. Yeah, I should sit down. All right. So
when we're in class, do we have to be on Zoom?
Yes, I would very highly recommend that. It is just we just look at it as a meetup. It's a big gallery and we're all going there. And it's just gallery of minds, essentially, and that's why we just, turn on the, yeah. All right. So all of you guys switch on your cameras, okay? Hey, Sydney Furman. Yeah, where is this? The other Sydney is in my 2B. Grewal, Sydney Grewal. There's another Sydney in class. Okay, I told her there's another Sydney, but yeah, okay, Sydney Furman. Welcome to class. It's the first time I'm seeing you, actually, I think. Yes?
I was in class last Tuesday.
Oh, you were here, but I didn't see you because, I was totally messed up with my Zoom. So welcome to class. All of you guys, right? Anyone here that I hadn't, personally welcomed to class before? But Justin, welcome to class too. All right. I know you're already ahead in some of the quests. So I know a bunch of you are already ahead in a bunch of these quests, okay? Keep in mind that, there is no fun. I should stop while, stop wandering around. There's no fun in just marching ahead, okay? It might seem like fun, initially, actually no fun, okay? Just, take a breather. Maybe that is the time to concentrate on some other class. People actually concentrate on some other class when something is due here. Okay, so when you're ahead, that is a time when you can, focus on maybe, some hard linear algebra problem or something like that. Okay, so just don't keep plowing ahead. And my idea there is that even though it may seem easier to you, you're going to spend, give it its due, like a week, right? So maybe not like hello world and things like that. Eventually you'll find, right after quest 5, so binary search, the classic example, and you'll get it right in a day, right? One day. But then actually trying to get it in different scenarios, trying to get it to work, right? That is what gives you a feel for binary search, how it actually operates. And then you don't really need a computer or a language anymore. You just know, this is binary search, right? New language comes out tomorrow, you'll know, all right, how do I do binary search in that language? Rather than saying, do I need to know the language first, right? So you want to get to the nuts and bolts, and you'll eventually get there with CS2C. But I'm saying you can start right now. There's no need to wait until CS2C and say, the magic land of algorithms, that's where I'm going to learn about hidden structures. Just start right now and play with it. And before you know it, you'll actually dealing with the stuff. You'll be dealing with all of the stuff, and it'll be easy. Okay. So one of the things I wanted to mention was, anybody uncomfortable with anything that we did last class before we go into the demos? Okay. Before we go into the demos, not demos. Essentially, this is what we're going to do. This is a suggestion. We're going to take turns. Sorry. Okay. We're going to take turns among all the people here. Among all the people on Zoom. We're going to start, everybody's on Zoom, right? Everybody here? Okay, everybody on Zoom, including the online students. We're going to take turns, and we're going to take 5 minutes or something to show your code. If you haven't coded it, you've got time from now until the time your turn is up, okay? So that means if Isidore or someone starts, or Panini starts with some kind of a demo of, online GDB, click on that and then start showing, I don't know, what is it we coded last time? Is it change your name with, random letters changing to like O or something like that. Okay, you can click on that link. Khrushchev, where's Khrushchev? He joined. I hope he hasn't dropped this class. Okay, actually, it was really fun to have him code and everything last class. Khrushchev, are you here? The thing is, because I can resize the rectangle, minimum rectangle size on this thing. If you're here and I can't see you, you got to somehow speak. How about this? Because Zoom creates a transcript of all of the people. It creates a transcript and I can download it. Everybody in class right now, today, right? In the Zoom chat, just say present, okay? Present, and then you don't even have to say present Benjamin or something like that, okay? So I know present, and then the Zoom name will tell me, oh, all right, Benjamin was here today, okay? And that's a really cool thing. For me, I don't have to take a roll call. Then I can just have a program, right? And just write a little Python script to say, all right, who was present and add so many points, okay? Yeah, so that is cool. Hey, that's really cool. That's fantastic. All right, thanks. Thank you, Zoom, for that. What is that? Caesar, orange. Oh, it was just your sleeve. Okay. All right, okay. All right, I'm going to sit down, okay? Okay, how about this? Does anybody have any problems at all with the code that we had? How about someone pull up the code? How about Ian? You want to try that? Okay, share your screen. Share your screen. No, I shouldn't be pointing at him, okay? I can see him sitting right in front of me, but I want to point to, I can see you here. Yeah. All right, okay. I can see you here. So I should be pointing here. Say, yeah. So if you want to take the screen, and then, how about this? We're not even going to click on that link. Right? So the link that Khrushchev posted, we're not going to do that. However, we're going to just do the same thing over again from scratch. How about that? Just like, exactly the way that any artist taught, I think, right? You just shown the shape first, and then you have to traverse the shape many hundreds of thousands of times, right? Maybe even in your sleep. The same thing over and over again. And sometimes you may introduce variations, but the funny thing is, you'll notice that each time you introduce a variation, it won't be a random variation. It'll be a variation that has some kind of aesthetic value to it, right? So if you're singing a constant note and you practice to sing a constant note, but there's a million, noisy ways to change a note, even a constant note over like 2 seconds. But if you kept having to do that over and over again, you'll discover that certain patterns of variations are actually more pleasing than random variations, and you'll get to identify those. This is the same in programming, I think. Okay, so we're going to take the same thing over and over again. We'll program it again, and first, I think you'll find that it's actually not so mysterious, and it's actually very simple because I can just do it in my sleep. And the second thing is, you're going to get slightly bored with it because it is the same thing. And then we'll jump from student to student doing the same thing, but you got to follow, okay? You can't, say, switch off and watch a TikTok video, right? You got to follow every student, even though they're doing the exact same thing that you did also. Yeah, is that okay? It may not be the exact same thing because their make and name might be slightly different. But the one thing we're going to do is right now, we're going to do this exact same thing again. We get to the same place. Instead of clicking on Khrushchev's link, we're going to code and get to the same place. Now, is a screen shared correct and all? Everybody can see Ian's screen and then some of the students, unfortunately, not all. Is that the right configuration for everybody? I think that's much better. Okay. And I think what we should do is, I hope this is what gets recorded. Okay. Maybe I switch to gallery. I can maybe see more of you. One thing you can do, Ian, is click on that blue. It's okay. You can see my mouse. Can you see my mouse? Yeah. Okay. Click on that one.
I can see there.
Yeah. All right. Thanks for that. Okay. Well, actually, good. It's good having that screen there. All right. Yeah, I was doing the stupid thing of turning this whole monitor around your last class. Hey, that was so crazy. Why should I turn the monitor around? So I see. Oh, that's really silly. Maybe I should send an email to Mario or someone because it is having the camera facing this side means that if I want to have the camera that side, I have to tilt the whole camera around. But however, there is no need for the students to see this because I can always project this over here. So so the camera is this fixed? It's probably fixed, but I think the camera should just be detachable, like Apple magnet stuff, right? So you should just be able to flip it around, or whatever. All right, okay. Anyway, let's not get distracted. Okay, thank you for pulling me back. All right, just hit Control A and then hit delete. All right, we're going to start from absolute scratch. And in fact, you're going to type and I'm going to walk you through every step of the way. And if you don't know something, what we can do is at any point, and it's not just Ian, okay? Lots of people, and I'm just using Ian as an example, but I know lots of people who email me too. Lots of people have absolutely no clue what to do. And there's lots of people who know what to do, right? I know, because I've seen submissions from, Vivian and Rebecca downstream, okay? So I know there are people that are already comfortable with the basics of coding, but 2A, we have people from a huge spectrum, and even people that from a different profession, right? Different profession. They spend years honing their skills in something else, and they've found out about computer science or been using computers and say, all right, now I want to learn about computers. I'll have the luxury of learning about computer science. So we have this huge spectrum of people. So we just have to be aware of that, okay? So but we have the luxury of time. Because we're already talking about loops. We're already talking about loops and branching statements. This is like week 3, okay? So we're at week 2. So we're already into week 3 stuff. So we have the luxury of time. So we make sure that everybody is on the same page before moving forward. So if you're already like sickly bored of loops and for these things, you're going to be even more bored, okay? Because that's what we're going to be talking about until everybody signs off, okay? So Ian, you should feel totally comfortable at any point. Anybody should say, hey, I want to totally understand that. I want a one-on-one person, right? And all that we need to do at that point is just, pick a random person. So many people in class who know how these things work. So many people. And we just say, hey, do you mind, coaching this person to the basics of this? Okay, so one-on-one, and it's not more than 10 minutes, right? So you're going to sit together and figure it out. Okay, how about that? Okay, if you don't know the basics, you're just going to get paired with a random person or a person of your choice. Okay, until both of you are comfortable. Okay, preferably not someone who right? Like if you're in a group sitting together at the same all at the same time, like like Kiera and Juliana and all those people are sitting in the same place, then I would say, all right, you want to split it up, and because you're seeing each other every day, every class, maybe try someone else. Okay, maybe go to the other side of the room and so on. Not this side. Okay, most of these people helping me in some way. Okay, but this side, you should just feel free to pick random people. Yeah, on everywhere, just mix and mingle. And also online. Okay, just don't restrict yourself to. In fact, look at the Zoom screen. Right, you can you should be able to, because it'll happen in chat, it won't get recorded, and then, all right, pick someone on Zoom, okay, and say, can you not breakout room? Oh yeah, breakout room is fine, okay. Just the two of you need to get into a breakout room and do the stuff. And if you're here, you don't need a breakout room, okay. You just need to pair up directly and work. Right, if you choose an online person, you're gonna go into a breakout room and work there, because I think that there's only one screen and there's too many people can't share at the same time. Is that okay with all of you? Is that a good plan? I think we'll use that for all classes going forward. Anybody who's not clear on any concept, right? Because if everybody's not in step when we're talking about advanced stuff, it is absolutely no fun. I can tell you that. Okay, this is someone in class who's just grudgingly sitting there saying, well, it's 20 more minutes before the end of class. I've been in classes like that, when I was an undergrad student and all. And the funny thing is, after much later in life, I think back to my undergrad classes, and I see some of those professors, because I remember all these things very clearly. I can play all this like a videotape in my head. I see all those professors, many of them are like truly passionate, okay, teaching me about fundamentals of electricity and circuits and incredible paradoxes and how to overcome them, and I was just looking at it from, yeah, okay, I need to get through this class. And so I don't want you to fall into that trap. You can obviously play it back in your head and get it back. But I think this is a great opportunity for you to just, let loose and get paired up. Everybody should be on the same page, because when we start talking about advanced stuff, even, advanced stuff, I'm talking about week 8 and so on. If you're not in week 8 material, you're pretty much failed this class. Okay. So aim to get at least week 8 material, meaning that about pointers, meaning objects, which objects is midterm. Okay, this is a good planning class. People can actually make a note of this. Okay, objects, up to objects, but no objects for the midterm. Yeah, up to objects, meaning all control structures, if, then, else, and so on. And then operations involving them, saying, hey, here's some code which has got an if loop and a while inside of that, or vice versa. And here's a value of I. What's the value when you get here? Okay, and the cool thing is, you won't have the luxury of copying that and pasting it into a browser and running it. Okay, like an online GDB, you won't have. If you do that for every question, you'll run out of time for the whole test. So you got to do this often enough so that it is like good practice, and you can just look at it and run it in your head instantly. Yeah. And that is part of the human instinct. Okay, so that is what I call the human instinct, which says that, as much as possible, I'm just going to use the mind to do things, because that is the thing that requires the least amount of glucose from me, or something like that. It may use a lot of glucose, but you should not shifting as much atoms around. Okay, so if you just imagine that accurately, and you just get that with practice, you just have to keep that again and again, and you'll know, right? With a very high probability that this is what is going on. Yeah. Okay. All right. So let's yeah. All right. Yeah. Are you good to drive with this? We're just going to talk, and you're going to type in every token, and at some point you'll just feel comfortable, right? If you're not comfortable at any point, you'll just say, I want a personal tutor, and someone will sit with you until you're comfortable. Yeah. All right. Okay. And you should like totally feel okay to, if you think that 2A is not your thing right now, just drop it. Who the hell cares? Come back. Maybe next year you'll think, hey, I want to program. Okay, then you want to learn it. That's the time to learn programming. Not say, well, you know what, at this age, people go through this thing and learn programming. That's total nonsense. All right, so just do what you want to do, but focus. Don't be jack of all trades and do everything. So just focus and say, all right, I got a long life, so I want to get deep into everything I do, rather than do breadth first, right? Because that's not even a clever enumeration strategy, I think, right? Or something like that. So you just say, I'm going to do everything one at a time, not all of them at the same time. Okay. So yeah, that'll be really cool. So if you're not interested, you should totally come back. You don't have to do the class, right? You can actually go and do the questioning and write it. Lots of people able to help you. Chris is on the Genius Bootcamp, and there's Namrata. So many people, doing the bootcamps. They'll all be able to chime in and help. So nobody should feel compelled by me or anyone to remain in this class unless they're genuinely interested in the subject, okay? Because you're just going to go beyond a lot of things. We're going to stick to the syllabus, right? That's a cool thing. And fortunately, I discovered a lot of really cool gems in the syllabus itself that I can spend a lot of things on to energize you. That's essentially what it is. A syllabus is a selection of topics from the subject that is designed to energize the student's thinking. That's all, okay? It's not a list of subjects that you should know about. All of this you already know. And we're just trying to say that, oh, you know what you already know, apply it to this kind of thing, this situation. A lot of people just don't realize. It's exactly the same problem, same kind of problem in a different situation, because they don't abstract out enough. They're always stuck in the low details. So when you're stuck in the low details, like in programming languages too, right? Later on, as you start program more and more, you'll stop thinking about bits and bytes. You'll stop thinking about, so your nodes even. Nodes, data carrying nodes, payloads, right? So you start thinking of higher level data structures. So the detail kind of fades away, but in the sense of genius that I told you before, right? So the expert versus novice difference, where, you know, experts tend to forget a lot of the detail but they know exactly how to get there in logarithmic time. This is like ascending the tree in full confidence that it is a finite discrete tree, meaning that any point you want, you can get there in logarithmic time to the base of that finiteness. Yeah. Yes. Do you know what I mean? So you have full confidence. You know with very low probability that, you know, you're gonna yeah. All right. So that's why you do that. So actually, it's very interesting. I had a very interesting conversation with my son about this earlier today, and I totally forgot. But I thought, hey, that's really cool. I should, you know, tell this to my students too. They'll also enjoy this. But I totally forgot now. If you remember, let me know. Okay. So, pardon me. All right. So later on, right? You know, it'll just lead to distraction. But it's kind of related, information theory and all. Okay. So anyway, just all right. You good with that? Just delete. Start typing. At any point, you can say, I don't want. You know, I just want to talk with a, you know, another classmate. Yeah, okay. And you just say, I'm going to go to a breakout room. That's okay with. Is that okay with you? Because, you know, I see your face and you're kind of anxious and all. So I don't want to. I don't want to put you on the spot and say, hey, you got to type now, right? So if you don't feel comfortable, don't do it. Okay. But if you want, if you're up for it, totally okay with all of us. Okay, we're all behind you. We're going to help you. Yeah, and you know, it'll also be, you know, because there's you're thinking maybe you're the only one. I bet there's a lot of other students like you. Yeah. And so they can say, well, you know, I didn't have to go through that, but I can look at what Ian did, and it's, you know, I can actually put myself in his shoes. Yeah. Okay. All right. Good. So here's what we're going to do. If you guys all are okay with that, yeah, I'm just going to sit here. Okay. And just remind me to sit, you know, come back here. Just Command A, Control, is this a PC? Mac, Command A, hit Command A and delete. Okay. Command A and delete. Command A and delete. It's really cool, right? I don't have to bring the Mac, but I have this really cool Optiplex because I couldn't do it last year, or even, you know, before the COVID. We had this computer, and it wasn't like this. Okay, now I can. This is a nice computer to use for travel classes. Okay, all right. So we got a blank slate. Everybody okay? So we're going to start from blank slate. How much better can a class get? We're actually starting from a blank slate all the way to complex data structures eventually. Yeah, but we'll actually get to linked list even in this class. Yeah, okay. So here's what we're going to do. First thing we're going to do is hash include. Okay, anything you're unsure about, what you can do is actually, you know, put 4 forward slashes on the right side. Okay, so it's just a tag for you so that you can say, when I get into a breakout room with a tutor, or, you know, not a tutor, breakout room with a friend or a classmate, or maybe a sitter or someone like that. Okay. You know, not like a breakout room. You can actually say like 10 minutes. Well, other people get in a breakout room. I'll just pause for 10 minutes. Okay. I'll just walk around at that time. Maybe I'll take a break. Okay. That time you get in the breakout rooms. Maybe, you know, you guys, you can talk. All right. And to point to places where you have the 4 slashes. Okay. And say, hey, what is this? What is this? So just to keep yourself, you know, intact for yourself. All right. All right. So in hash include less than sign. Okay. That's the left angle bracket, less than sign. Yeah. And inside, yeah, that sounds fine. Hey, what happened? The right side came automatically, or did you type both?
No, I type one by one.
Oh, you did type both. So it's not autofill.
Two.
Yeah, VS Code does that. VS Code does that. But I was surprised that this is a web app, right? This online GDB.
Like one by one.
Yeah. Thank you. All right. So inside, you want to say hash include IO stream. Okay, IO stream. And if I'm not doing this, you know, exactly the way that we did last class, someone just remind me. Okay, so let me know and we'll correct. Okay, so enter, and one more, and then say using namespace standard std. Right, using namespace standard. What time is it now? So we got a good time. Are we good on time? Yeah, you guys should, you know. How do I get the clock? How do I get the clock on this thing? Just look at my phone. 6:35.
Exit full screen.
Yeah, but, you know, but there's no menu bar. I got to configure Windows, and it'll just get erased. Yeah, I see. Not the mouse. I see Windows key once. Oh wow, but no time there. Oh, I see. Okay. All right. It's just different. Yeah. Yeah. Even though I know this, right? I've used a Windows machine before. I just don't forget that. Thank you so much. All right. Okay. So using namespace standard, you want to put a semicolon after that. You just get into the habit. Okay. So I'm saying you put semicolon, but after a few times, you'll actually know. Right. So enter one more time. And implicitly, you're also using my style because I'm dictating the code. But when you start typing, you'll just use your style. Maybe it's the same as my style or very similar, but eventually when you start typing, you'll use your own style. Okay, so now we're just using my style, right? Or at least at this time of time. All right. Right. So using namespace standard. Okay. So now let's put a comment there just to make sure that we say what we're going to. This is a program and a comment, 2 forward slashes. Yeah, and then a space, and then start typing. This program will ask for your name, make a change to it, and print the changed name. Ask for your name. Ask for your name. Right? We've done this a lot. At least a couple of times before. So we want to do it many times so that we just get comfortable with it. Okay. Even as comfortable as me. Right? I'm just sitting here and talking about the code. Yeah. You should get at least as comfortable as that with this code. Yeah. Not like complex code. Sometimes you have to pour over the notebook and make sure the numbers add up. But things like that you should get. That's only practice. Okay. And it's not just, I've done this with class students many times. It's even before students. You'll get, I think. All right. Okay, good. So you should do that now. You should wait to become teachers and then, all right, I got to do this many times for students and then I'll. Okay, cool. This program will ask for your name. Make a change to the name using a function. Okay, so let's make it very clear. Make a change to the name. Make a change to the name. Right. If any part of this is not clear to anyone, okay, not just Ian, anyone, please don't use a chat. Okay, I'm not even looking at the chat. Okay, I only got limited real estate there, so you got to just speak up. Okay, just pipe up and bust into the unmute yourself and talk. Nobody's looking at chat. Is anybody looking at chat? Well, except the people that are typing into it. I don't know. No? Yeah. Well, I don't know. Everybody's quiet, but don't use chat. Anybody who wants to say something, and I shouldn't be the only one talking. Okay. In fact, I was telling my son earlier today, I should actually practice speaking at this volume all the time. Because I'm just talking loud all the time, but it just limits the number of hours I can keep talking, I think. Yeah, but I think this is okay. Can you all hear me at this volume? Yeah. Okay. All right. So I just need to practice more, staying at this level. And if I just get higher in volume, just let me know. Because I think it also sends you the wrong message. That this is really important. You guys study this, and it could be that oh, there's like 55 topics and all of them are really important. No, they are technically. But, all right, okay. So this program will ask for your name and make a change to the name using a function. Okay, so a function that we will write. And in fact, what we'll do is after using hit enter. After using hit enter. No, in fact, hit enter. Click before name. Click before name. Yeah. Break it into 2 lines. Yeah, that's much nicer. Nice, much nicer. Make a name to you with the using a function that we will define. You may want to go to the next line. Yeah.
Next line.
Yeah. Okay. Well, you seem to have the right idea anyway. Yeah. So space and then that we will, and you want a space before that, so that we will define. Yeah. And then put a. Okay. All right. And then it will print the changed name on the console. Again, break into lines and all. Changed in past names, changed name, and you can go on to the next line, like you said, before bring the arsenal. All right, changed name. It will print the changed name. It will print, print, and then you can go on to the next line right there again. Yeah, print the changed name. Yeah, all right. It will print the changed name. After a suspenseful series of messages due to. I remember her name because I think Krishav actually wrote the name. I saw the video. Was this the video or the link or something like that? Somewhere in there. This is due to Erica Altamir, and it's actually Erica Altamirano. Okay, so that's her name. Is someone talking to me?
No.
Oh, sorry. There are more plug points if you're just looking for plug points.
Well, there is the one by the table, so without the I.
Yeah. Yeah. Oh yeah, there's a couple here too. Oh, that's probably for, laptops and stuff. Okay, yeah. So after due to let's just attribute it to her. Really cool. She I don't know where she is right now. She's probably in a different state. She said she was moving from state to state, and maybe she says curious and says, hey, what's CS2A up to? And she goes to this thing and she looks at this video and says, hey, that's my name, right? And except I don't remember the exact quarter she was in. But okay, right after a suspenseful series of messages due to Erica, E-R-I-K-A, Erica, E-R-I-K-A with a capital E. Yeah, and her last name is Altamirano. All right, Altamirano. I hope I'm getting the name right this time, okay? Because I saw that someone said Altamir, but Altamirano, right? And I think it is 2020. This is 2023. I think she was a student in 2022. And maybe it was spring 2022. Okay, this is spring 22 in parentheses. It says spring 2022 in parentheses. After Erica Altamirano, you can say parentheses. Parentheses. Oh, I see, parentheses. We're going to be using a lot of parentheses, okay, in our code. Yeah, okay. Parentheses means left bracket, okay? Parentheses means left bracket. Well, basically, parentheses means left and right bracket together. But sometimes I just say parentheses. That means open the parentheses. Put the left bracket there, and after a while, we'll put the right bracket, okay? Yeah. Usually, this is what we do. I don't know, is this convention research and all? They put a space after, yeah, there you go, right, yeah. And I think you can say spring 20, yeah. Oh, not curly brace. Is that a curly brace? I can't see. That's the other thing. His funny thing is, yeah, okay. I can tell the difference in this font with between curly brace and you got to make sure parentheses has got to be. Yeah, parentheses is that a? Is this correct? Is this all right? Okay, I don't know. Right, full stop. That's enough. Okay, and then yeah, that's it. Is that what we're going to code? That's all. Yes. Everybody okay? This is what we're going to do. All right, good. All right, so now what we want to do is all right, enter. Now we know that because of this thing that we want to do, like suspenseful series of messages and all, we want to use a Unix system call because we know this is a Unix machine, and this Unix call is called sleep. Okay, I think it's called sleep, right? Sleep, right? In fact, on the next line, you can put another comment here. Okay, no, go up to line number 2 and hit enter. Up to line number 2 and hit enter. Yeah. Line number two. Yeah. All right, hit enter. Yeah. All right. Now you want to put a comment there. This is basically writing a lot of comments before we write code, because comment meaning what you've done before with the 2 forward slashes. What we're doing is spelling out in what we're trying to do in the program before actually cutting any code. That's what we're doing. And it's actually a very good practice, especially if you're unsure of anything in your code, right? Or if you don't know how to approach a problem, start coding, but you don't have to cut code. But instead of coding, you're just going to put a lot of comments and saying, this is what I need to do. Yes? Is it okay? Maybe it doesn't make a lot of sense right now, but after question number 5, I can bet, okay? This is going to be like super duper useful as a tip. So all you're saying is that, right? Maybe this is how everybody starts programming in my class. Okay, this quarter. Just see if it's going to really work. Is whenever you start coding, if you don't know what to do, you're just going to write comments like we're doing now, right? Yeah, all right. Okay, we got a few things like simple things like hash include and stuff. We'll put there. Okay, so here, all right, now a comment. Here, what we want to do is we're going to use type in a comment there, right? We're going to use a special effect that uses the Unix system call. Okay, so type in, and we're taking the pain to do all this for the benefit of really. All right, they should say thank you face-to-face students for doing all this. Okay, because really I don't have to spell this out and type this into the code. And we're only doing this for people who don't watch the video and write to the online GDB link and clicking to read it, right? Because otherwise we don't have to do any of this shit. Yes. All right. So if any of you feel that it's unnecessary, we can actually move on, because people can actually read the watch the video and know what the hell is going on. But if you think it's overkill, let me know, because we shouldn't be boring anyone in this class either. Okay. So on line 3, we're going to say we're going to be using and you can type You can type at regular speed. I think we're just using English right now, no C++ code. Okay, we're going to be using a special effect, using a delay with the Unix special effect, using a delay. All right, using a delay with the Unix system called sleep. Right, with the Unix system called sleep, which requires us Unix. Oh no, Unix UNIX. Okay, it is an operating system, right? Or Linux or whatever it is. Yeah, UNIX. A Unix system call. Okay. System call. Hey, Vivian, you good? All right. Okay. Well, you had to turn around all the time. You good now? Yes. Okay. All right. Is everybody good? Is everybody on the same page? Yeah. Okay. All right. So, all right. Yeah. So system call. Yeah. System call on the next line. Sleep open close. Okay. System call. In fact, it'll be nice if you break the line after system, right? Or after Unix. If you break the line after Unix, then it'll sound nicer also. Yeah. Because it's how a phrase ends. Yeah. Then you'll already be primed to know that the next line is coming. Okay. Yeah. System call, and then after system call, you can say sleep, and then parents. Okay. Open close. Another way that many people say parentheses is open close. Open parentheses, close parentheses. Open close. Yeah. All right. And usually what I do is don't put a space after the sleep and attach that to say that it's a function. Yeah, they're all stylistic conventions due to me, right? So we're following them now because I'm guessing that you guys don't have one of your own. Yes. Okay. So there's a risk here that there's a bias that the next one you consider, you're going to compare it to this. But all the time, it's better than having nothing on your so you should consider this your first one. Okay, you're going to obviously change it and customize it. And start with something good, and then you can make it your own. All right. System call, and in fact, after call, put a comma. Right. Put a comma. These are just things you'll just get used to eventually, right? After the word call on line 4, yeah, I put a comma. Right? Sleep, for which we need the Unix, for which we need the following include file. Okay, so we had to spell this out in excruciating detail, but I think it'll be very clear. Someone who when you share that online link, like Vivek did, not Vivek. Who shared the link last class? Krishav. Yeah. We did the same thing last class, and then it's natural for lots of people to forget. Okay, if you forget, yeah, that's what everybody does. Nobody remembers the first program they ever wrote. Okay, but you got to keep doing that enough times so that you don't forget. But it's surprising. The funny thing is, lots of people think that I had to repeat that 50 times in order to get the hang of this program, and they think that, well, there's so many other programs I got to learn. Do I have to say 50 times this effort? And a lot of people are misled into believing that the amount of effort they put into the first task is that X times for each of the X tasks to follow. But that is not the case. That is not the case. And you got to, and all the evidence, everything in your life seems to point to X times the effort. And so people are just reluctant to take the first step because they think that the remaining steps are going to take X times the first step effort. So you got to snap out of it. And maybe you just associate with people who, snapped out of it, and they can just convince you. Just break out, okay, and stop limiting yourself. And so system call sleep. All right. So on the next line, let's complete the line. Okay, system call for which the following include file. For which the following include file. Yeah. For which the following include. Is this being recorded, by the way? It is. Okay, it's automatically recording. I didn't even. Maybe I started the meeting here. Okay. All right. Okay. All right, so for which the following include file. Okay, this is jargon. All of these things you got to get used to. Okay, that's why it's like super duper important. When I say delete the comma and so on, it's not just stylistic. You're going to encounter this millions of times in your life as a programmer, and it's just getting used to it. Once you get used to it, then you can peer past what other people are telling you, right? Because when you're high level discussion and people are talking about stuff, you can't afford to think about the low level detail. Yes, because things are moving at high speed. Yes or no? You don't think about computer science. Think about other things that you've been involved in, right? Talking about someone at a high level of detail about something. And then you can imagine how painful it is for you to slow down all of a sudden. Or keep back and forth also. Even, musicians, I think, right? They tend to stay in pitch more comfortable stay in pitch than to keep back and forth. Okay, that's why these pieces are always, interspersed very tightly, and people know that they have the right kind of energy for these things. All right, so
always need to put a comma at the end?
no, you don't. Okay, that is why you don't have to. We're doing this only for someone who's, Yang is going to share the link, and they're going to click on the link. Okay, if it's painful for you guys, we're just going to type. Okay, and it'll be fine. Like anybody watches a video without having to just click on the link, and click on the link, they'll see the whole program, and you can find the whole program anywhere on the web. Right, you just go to ChatGPT and say, give me a program that'll do this, and it'll give you a much better program in C++. Yeah, without the comments optimized and everything. So you can find the program anywhere. So there's no use in just, making this video, unless someone watches the video and watches the program happen. I think there's, if just the link alone is not that useful, but the link will be useful after having watched the video. If someone wants to click on the link and say, now I want to go to the link and start playing with the program. Because when they're watching the video, they'll think, hey, why is Yiheng not doing this in make a name? I wish he was doing this, or something like that. Or maybe, Yiheng is changing everything to O. If I was Yiheng, maybe I'll change everything to Y. All right. And then you wait until the end of the class, and Yiheng shared the link, and you can go to the link and then just go to the code and change that one thing. All right. Then you have the fulfillment of trying your own make your name also. Right, and also having to play with Yiheng's code and sharing, and everybody will be happy. It's fun. It's more fun. During the learning stages, at least, I think it's much more fun together. Okay, because you can't expect everyone to discover exactly the same thing at the same time. Okay, a bunch of children in a playground and lots of toys. You can't say everybody's got to go and now learn how to use toy number 1 and so on. You got to multiplex and say everybody find the most interesting toy. Right, 5 minutes, play with it. Okay, after the bell sounds, everybody's got to drop the toy and go to the next one. Okay, and at the end of the period, everybody knows how to use most of the toys. Yeah, I think it's a sensible thing to do. I don't know if you want to maximize your something like that. Okay, so let's start talking about that. Okay, so here you're gonna say hash include. Oh, I'm sorry. Yeah, is you're going to say exactly the same as before. I'm sorry. Yeah, I'm starting talking hash. Yeah, hash include. Well, it's kind of cool. It's auto completing and all. Less than, right? Again, you get in the habit. You're going to get in the habit of saying hash include. There's only 2 things that can follow it. Okay, either a less than or a double quote, and you will discover very soon what the difference is. Okay, maybe it's a very good post for someone to do on Reddit. Okay, on Reddit, how about someone say, hey, you know what? What's the difference? I find these 2 kinds of include files, one with double quote and one with angle brackets. What's the difference? Right? Someone asks, someone answers, and you got a link for your final report. Yeah. And practice in trying to explain something to someone. And then, maybe it's very technical here, but maybe, you're trying to make small talk with someone in a bar, right? But you can explain the same thing, right? They, in a way that makes sense to them because, you've explained it enough times to know that, this is really what it is. This is why we do an include, right? Oh, maybe we do that in life too. Maybe there's a situation in life where we just remember something and just regurgitate, right? And just go on autopilot during that time. And that's exactly what happens in a compiler. Yes. It just goes into that file as though it is part of the source now anymore. Right. But I shouldn't be telling you about all these because these are all interesting things. Okay. That's what I mean. These are interesting things if you get deep enough into them. Right. Don't skim the surface. Hey, Vivian and Rebecca. All right. Are you guys browsing the internet or something? All right. Okay. All right. Okay. I thought I saw you guys typing. Okay. So don't do it now. Okay. So I have a request for all of you. Okay. Not just Vivian and Rebecca. Don't type the code now. Okay. We just I think it's more fun this way because Yiheng is uncomfortable with the code, and I'm pretty sure there's lots of people because especially since a bunch of people joined today. Okay. I sent ad codes yesterday, so I just want to make sure. It's okay. I can say you guys got ad codes you can pick up on your own, which is the email that I sent them, which is kind of harsh. Okay. I say, you're on your own. You got to pick up on your own. We're going to keep marching on the same. I don't think it's as much fun. I think so. Yes. This is like 4 or 5 people. And so I just said, we don't lose anything. We're talking about loops. We'll just say today, we're just going to rerun, have the same thing over and over again. People who are already comfortable. Just imagine that we're typing this thing here, and then Yiheng will share the link, and because that way everybody will do the exact same thing, right? Rather than you doing advanced stuff now, when you demo, eventually it'll be out of whack. So you save that for later, maybe, and wait until he shares the link, and everybody will write their own version of make a name. Okay, make an idea right now. Okay, make an idea right now in your head, but don't code it. I think the fun really isn't waiting and coding all at the same time, like in chess. Like in chess, right? So they formulate all these moves and they're waiting for the clock to go so they can, so that, yeah. All right. Thank you all so much for that. Okay, all you guys, I can see all of you, unfortunately. Okay, so in fact, I can only see there. Right? Maybe you guys elsewhere. But I think Roger and Ong, maybe there's a whole lot of you. But I did ask for a lot of people to enroll in class. Yeah. So this is an experiment. This class is an experiment, okay? Because Foothill wasn't. I think the last dean we had, he wasn't interested really in offering a face-to-face class at this time for C++. And it's an experiment, and I thought it would be cool as an experiment. So we kind of agreed that it'll be a cool experiment to run, because if we offer the C++ at this time, then that means even professionals in the field, or people who are looking to reskill, like who've had experience in other fields and say, I want to learn about computer science. There's a lot of people like that who will attend and take advantage of these things, because community college shouldn't be tending to high school students. Right. I know we have a bunch of high school students, but it's community. We have high school and other venues for that. But a community college should be targeted, I think, in my opinion. I think value-wise, okay, value-wise, I think community college education has the most value for people that have done something else, right, and want to learn a new skill. Because young and energetic people, they don't need to come here to learn. Really, think about it. Yes, they have like 1,000 sources. And if I don't teach them, they'll find out anyway. But someone who's doing something else, or maybe even an expert code in Python, okay, who says, I want to, I know Python, I want to learn C++ now, right? And then those are the kinds of people, they can do this because they're going to be doing Python all day, and they're going to be doing this in the evening, and that we don't have an opportunity for them to do C++ right now. And we have, I think, at Foothill, we have a new track, another track. Teresa used to run this. I think it was CTE, okay? It's a CTE, Center for Technical Education, okay? There's a department called CTE, and Teresa is the head of that. Teresa Ong, right? And that is focused on evening classes, teaching skills like Unix, Linux, networking, Cisco routers. A lot of these things are complex, yes? Because it requires a lot of, even Linux, it requires a lot of practice to get used to the bash, or the different kinds of shells, or using a lot of shells and knowing that they're all the same under the hood. Yeah, it takes a couple of years of using this and building your own aliases and discovering at the end that it's not portable. And then you say, well, I'm just going to get to the core features of all of the shells, the intersection, rather than customizing one. And that only comes with maybe 10 years of use, because you get used to a particular operating system, a particular way of doing things, customize things. That's how we spend our youth, right? Making sure that the world bends to us. Right, but after a while, you get bored of it, and bored of bending different things to our will, and say, let's just figure out the intersection, and let's not waste energy trying to bend everything to. And we'll say, nobody wants to bend this way. Let's go that way, okay? And because once you find, I don't know how we get started talking about that. But basically questing is like that. Evening track, okay. So that is why I thought it'll be a really cool experiment to try. Not that we don't like this high school students. I love high school students, right? All the time. Even when my own kids were in high school, like Bonnie and my daughter. Because I love going through their math problems and working. I sometimes have to resist the urge to help, just like now, right? I know my daughter didn't like when I didn't help with some problems and all. But it's interesting, and that's what I'm doing with you guys, right? I'm never giving you the solution, hopefully, right? All of these problems you got to solve, because I know you can solve them. But I've done this many times. I know people that have done it many times, and but why should I do it one more time and take away that apple from you? Right, but you got to get it, okay? And don't think of this just as another community college course, okay? And like I said, and I said before, people say, I want to get up there, but in order to get there, I need credits or units. So I'll just do these check marks. But that is a wrong attitude in life itself, not just community college courses, okay? It doesn't mean that that is my goal in life, and all of these are just waypoints. Okay, you're never anywhere on your way somewhere else. You're right where you are at that point is the time and place that you need to be, and just be yourself at that time and enjoy it. Okay, so and that kind of attitude, even with programming, I think it greatly helps. I got like totally distracted. Okay, and nobody pulled me back. Okay, I had to pull me back. All right, then thank you very much, and sorry for inflicting very, very grandiose opinions upon you, but really, doesn't matter. It's just at that time, that's what I was thinking. Okay. All right. So hash include unistd.h. Okay. unistd.h. .h. Okay. So that's a funny name. It's hard to remember. That's why I put the name Unix in comments up there. So already people are primed to know standard Unix standard. I think that's what it's called, UNSID, right? There is a file somewhere in the disk, right, called unistd.h.
Why do we put two includes?
The first include file is a C++ library of such things like cin, cout, endl, operators, things that we use in C++. Yeah, all of that is bunched together and told to the compiler in one file.
So these are two different files.
Two different files. Okay, that's all. Is everybody on the same page now? Okay, because that concept is hard for beginners. I know, right? Previous students have gotten confused.
Because we are going to use the things that in these two different files include them.
Yes, yes. There are these two different files, and as far as the compiler is concerned, they're just there. It's like one line, but it actually expands out into that many lines. Does that make sense? And inside of that file, we have definitions of all these objects. Okay, we'll go into the details later, but there you can think of them like Python packages or something like that, or right. You can think of them as though they have the implementation and the logic too, but technically in C++, it's not like that. Okay, it just announces to the compiler. Okay, they're declarations saying, oh, here's something called CN. Don't freak out and die when you see something called CN, right? There's a guarantee that someone will give you something like called CN later on. That's what those include files say. Okay, so they're called declarations, forward declarations, technical jargon. Okay, not necessary to pass CS2A. Okay, but they're called forward declarations, and we'll be creating forward declarations. But after a while, you'll be creating bunches of forward declarations. And then you'll say, well, you know what, in this file, I got like 50 forward declarations. I'm going to cut them all and put them in a file and say hash include that file. Yes? That's what happened to you.
Are both of those files from the same library?
No, completely different. Yeah, IO stream deals with the IO library, input output buffered stream library. That's why it's called IO stream. They try to pick mnemonic names, I think. Yeah. Yeah, is that okay?
Do they have something in common?
They're both directives to the compiler. When the compiler G++ reads this file, yeah, it's going to look at the hash include and then say, well, you know, it's an angle. Here's what it's going to, unfortunately, it's going to be recorded. We're not going to put it in comments, okay? People can watch the recording and find out, okay? Here's what the compiler will do. Because, you know, eventually at some point, you're going to be enrolled in compiler theory. You're going to solve, you know, finite automata problems and so on and so forth. Yeah, okay? So this will come in handy. This is what the compiler will do, right? It's going to parse it into tokens and looks at this hash include. And it starts expecting that the next thing is going to be either an angle bracket or a quote, double quote. Yeah? If it's not either of those, it's going to complain and die. So it doesn't have anything to worry about after that. Yes or no? Okay. So if it's one of those, it knows what to do. If it's an angle bracket, it knows it needs to search for a file in some predefined path, right? It's got in there. It's got a series of paths it looks in, and you'll find it in VS Code and all these things. And I'm pretty sure, you know, online GDB has some environment set up there. Okay. It's called the include path. So if the compiler sees that, it knows that it needs to look in that path, go to the file system and find that file. Open the file, read the contents, and stuff the contents right here as though the file was physically present. Is that okay? Is everybody on the same page so far? Okay, that is called hash include. Now, if it sees a double quote, instead of looking in through that path, it knows it's in the current directory. That's all. Okay, it doesn't do a search. That's the only difference. Okay, so hopefully that saves a lot of time for a lot of people. maybe you can just bookmark it in YouTube. When we do the posting, if you remember what time it is, you can say this is the difference between, hash include. Is everybody on the same page? That's what happens. Now, one of the common mistakes I've seen many beginning programmers do is that when they include CPP files, source files, okay, no harm. As far as the compiler is concerned, it was hash include another file. Maybe it works even many times. Bad practice, okay, because it introduces all kinds of bugs. But anyway, I shouldn't be warning you about that because you should try that. Okay, try that, and you'll run into bugs. It's better to know what the hell happens. Okay, it's harder to debug your code when you have stuff included like that. Yes, okay, but don't take my word for it. Just do it. After question number 3, you're going to be working with multiple files. Or even you can say you have a function, you have a file with 5 functions. Say I'm going to have 5 files. File 1.c, file 2.c, and so on, and then a master file main.c, which hash include file 1.c, and so on. Yeah, that's an experiment. Yes. And here you're not even experimenting with C++. Gee, I got to speak. Yeah, you got to remind me that I'm talking too loud. Okay. Because really, think about it. This is not in the syllabus. This is not important. This is not frills. This is extra stuff, and I can afford to speak at a low volume here. Okay. All right. So anyway. So is everybody okay so far? We can just continue coding. Yes? Yeah?
Within the curly bracket, within the angle bracket, uni std, the .h, is there a .g.a? Is that a separate file that flows from a separate path?
I'm sorry. Hang on. Within I see .h, and you're saying, is there a file called .g for the library, for the binary, for the object code?
Yeah.
I think there is a Unix. Maybe there's a bunch. I actually don't know, to be honest, Roger. It's a good question to. In fact, it's a good question to ask in the Reddit, and it's just a quick Google search, because I think it's probably a bunch of libraries. Okay, a bunch of libraries. libunix.c++.ccc or something like that. Right? If you just Google, it'll just give you a list of libraries. Yeah.
How do I know those files name?
That is just by experience, okay? Because now, really, no, not really. Actually, if you want to use sleep, right? And obviously, if I hadn't told you about sleep, you wouldn't know. Yeah. So I said, Erica did this.
You say sleep is in a Unix standard file, right?
I'd go to Google and say, I want to use sleep in C++.
So they will tell you which
file. Try it right now. Just open another tab. Open another tab. Right, and say I want to use sleep in a C++ program. Okay, no, even if they don't have AI, this is a pretty good match. I'm pretty sure. Okay. Okay, so I click on the first link. Right, so the very first one. I'm pretty sure. Yeah. There you go, and it tells you exactly what the hell you need to do.
So now this will allow us to use the sleep function within our code.
Yeah.
Even though we didn't create it.
Yes, and we can use tons and tons of functions like that. All right, and the cool thing is that the power of Unix. Everything you can do in Unix, you can do every single thing, right? In fact, even pipe data from you can open connections between programs, fork things, and connect from one thread to another. So we have fancy wrappers around them, right? Saying we have this thread and fork and things like that. So we'll give you a library called POSIX or something like that, so that you don't have to call fork and manage the semaphores yourself. But really, all of it is there's no rocket science there. But all that's happened is that they've wrapped a nice set of functions. So it's useful to know what these libraries do. But at the end of the day, you should be at least familiar with forking and stuff like that, and spawning and overlaying. The code is super duper simple, like 1 week of experience, 1 week of practice with Unix system calls. The system calls are so super duper useful. So many things you can do. Communicate across networks. Later on, maybe Roger goes off, flies off the Uranus or something like that. Okay, later on, maybe it's a different protocol. Right, and then Eric or Isidore could basically just sit here and go to online DDB, right, or some onlinedb.future.com, right, and say I'm going to communicate with Roger using Unix system calls, and he opens a socket and he can do exactly the same program as he did today, because the backend would know how to translate from here into some intergalactic signal, and we don't have to worry about anything at all because we're just using a blind function called open a socket, and that is available in Unix. Because everything is presented to us as a file handle. So the only thing we need, that is the genius of many of these things, is that, don't try to learn all of the, bullshit nonsense of all these high level abstractions like Django and shit like that. Okay. Just learn the basics and fundamentals. And then later on, you just know, right? So someone comes up with this buzzword, ask them what it is and break it down. And you know exactly what the hell it is. Yeah. So if you know the basics, it doesn't take a lot of time. And I usually ask, because, people sometimes come and talk, use buzzwords. And sometimes I don't know what the hell they're talking about. But then when I ask them to break it down, I know exactly what the hell they're talking about, right? So it's just, and the problem is you can't keep up with these things, okay? That is my experience. Because the buzzword of today is not the buzzword of tomorrow, right? But they're all exactly the same thing. And so it's a much more efficient path as a human to say, I'm going to get past the buzzwords. I'll just get to the bottom of it and then let the buzzwords change. And then later on, someone could say, well, this is what the concepts are. We got a new name for it today. Right. And so that I think is the safest path. And so I highly encourage all of the students. And in fact, later on, after this program is done, if anybody's interested, if, especially if online students, right, everybody is interested in machine learning and AI, right? Machine learning and AI. And I think, Justin certainly, made a post saying he was interested in AI. And, obviously you're going to learn computer science, but I was thinking today that, actually there is an AI or machine learning problem, which usually people learn in grad level courses or, undergrad high level, machine learning 101 or something like that. But I thought, it's called gradient descent. Okay. It's like super duper simple. It just requires basic math. You don't even need to know calculus. Okay. So you don't even need to know calculus. Gradient descent in 2 dimensions, and I could do that. So, and that is machine learning 101, because essentially that is essentially what you're going to do. Gradient descent is, you got a parabola, 3x squared plus 5x plus 7 or something like that. Okay. And let's say, all right, so it's going to be shifted, and right. So, all right. So, and you want to know what the coordinates of the minimum point is, where it goes down. And that is a very useful skill to have. Now, one way you can do that is obviously by differentiating it and setting it to 0, right? 3x plus 5 equals 0. So x should be equal to negative 5 over 3, right? So at the point, at the x point, 1 and 2/3, so somewhere between 1.5 and 2, you'll see the parabola bottom. Actually, you can go to Desmos, right? So you actually go to Desmos. We'll just take this quick diversion. Ian, I'm sorry to put you to sleep, okay? I'm very quickly excited about it. So just open another tab, go to desmos.com. So we'll see a minimum, right? And I'll also give me a chance to explain the problem. And if we need, after this problem, we'll come back to this and do this, right? If you got enough of you are interested, okay? It's kind of machine learning, right? So yeah, in the window, type y equals, what was it I said? X squared plus 3x plus 5. X squared plus 3x plus x squared plus 3x plus x. I think it was 3x. Yeah. No, I think it's 3x squared plus 5x plus 3x squared plus 5x plus 7. 3x squared plus 5x plus 7. Sorry. 3x squared plus 5x plus 7. Because otherwise the slope doesn't. Is it?
Yeah, erase everything. 3x and then 3x squared y equals 3x squared. 3x squared. 3x squared.
Yeah. No, plus. Okay, all right. So I think that's about, yeah. So let's say if you wanted to find the minimum point, and the reason I say this is so useful as a skill, generally as a programmer, okay, you're going to do any kind of problem, you're going to have a quantity and you're going to minimize it. And most of the time, what happens is that you have a model and you have an equation, which is very rare. And, it requires a stroke of genius sometimes to find the right equation, because many times it's a discrete world and you cannot come up with a continuous equation, right? Even if you use sigmoid function and make it all continuous and so on and so forth, like that's what we do with neural nets, right? Because neural nets, essentially like perceptrons, they're like, 2 states. They're, triggered, flash, and then go into the other state. But that's not that you can differentiate that. If you can differentiate that, you can't do this interesting algorithm, okay? This is the reason why we the basic unit of the neural net. Later on, when you do machine learning, you learn this, okay? This is the reason, okay? So I think, right? And people should also obviously, chime in the red too. So let's say that, if you want to find the minimum, the easy way, analytical way, mathematical way is to say, well, I'm going to differentiate it. Okay, I'm going to differentiate it and say, what was the equation? Anyway, I forgot. 3x squared plus 5x plus 7, right? The 7 will go away. So 3x squared plus 5x is the derivative and equal to 0. Yes, I'm not using the whiteboard really, but I don't have to. Please let me know, online guys, if I need to, or you too, right? If you want me to write it out. But really, just imagine this: 3x plus 5 equals, when I use these symbols and math stuff, I noticed that some first year students, not all, some first year students just switch off. Okay, just switch off, saying, well, it's math. I'll come back later when they're not talking math. Please don't do that. Okay, because that is really ultimately it just comes down to fixed mindset, saying, it's that language I don't understand. It's Chinese. I don't understand that. No, you can actually make sense of it. So math, you just say it's just a different language. In fact, it's a much easier language than Chinese, really. Another human language. So math, C++, you're here learning C++. Math is just another language. So just learn it. So anyway, what I was saying was, one way is 3x plus 5 equals 0, because you want to set the derivative to 0 to find the minimum. And you know that 3x plus 5 equals 0. So x should be minus 5 over 3. Yes, that's 2 and 2, my negative 2 over 2/3. Yeah, and so is that not right? It's not? Oh, is it? Oh, whatever. Okay. Yes. Yeah, I'm sorry. Yes. 6x plus 5. Oh, so that's why it's 1 point something, is it? Oh, well, it should be less than 1. Yes. In that case, it should be less than 1. The minimum should be less than 1. Yeah, it's 0.833. Yes. Right. So at x equals 0.833. And so you set that to 0, and then you plug the value of x and you find the value. All right. So that is the analytical way. That's the old way before computers. Okay. This is how we found we could actually traverse complex surfaces, because I'm only teaching it to you in one dimension. Later on, when you go do the actual course, you'll do the exact same thing in multiple dimensions. And you're doing the exact same thing, but instead of what we're doing now, later on, right, basically calculating slope. Gradient is basically a slope, right? There's sometimes you see these road signs saying steep gradient, steep slope. So you won't calculate the slope, and don't take the derivative or anything. At that point, calculate the value of the function, add a small amount, delta x, and calculate the value of the function again. So you got two y values. Yeah, and the difference between them is the rise, delta y, y2 minus y1 over x2 minus x1. That is your derivative, and that is also your slope. And if it's very high, the slope is high. So the genius of gradient descent is to basically make use of the sign, right? And it says that if the slope is positive, then there is a minimum to my left, or at least, if I go to my left, I'm going to be better off than here. Okay, that's all. Okay. So, and that thing, that the delta x that you select is, in machine learning, it's called the learning rate, or the eta, right? So basically, if it's small enough, then you'll actually settle very close to the actual minimum. If it's big, then you come here, and then you got to go to left, but then you jump more, and then now you got to go right, and then you get oscillating back and forth instead of settling here. So that's just more energy. And then, there's lots of approaches you'll do in grad stuff, or even in, later on in machine learning. There's different ways in which dampen when you get to a local minimum, so that it, settles there and so on. That's all topics of machine learning. But as I say, they're all hacks. Okay. Like, they're all hacks. The basic insight is that, just by following the slope, you can get to where you want. Well, you can have many minimums, and you can settle in a local minimum and say, well, how can I get from a local to a maximum? That's all of those are hacks. Okay. Like, simulated annealing and so on. Anyway, that's what we're going to do. So if anybody's interested, we'll actually do that. It'll like 10 minutes, okay, 10 or 15 minutes, we can actually get something done. We'll just come up with a random parabola, or ask people to type in a random parabola, 3x squared plus, and we'll say, at the minimum here is that, and we will not do it analytically. We will not do it by, we can take a derivative. Calculus, after all, is supposed to be automatic. Yes, the word calculus means automatic, right? But we're not going to do it analytically. But we'll actually use it, do it iteratively, programmatically. We're going to pick a random place, any place, a random place on the parabola, and say, at the slope at this point is this much, and my learning rate is this much. So I'm going to step to my left a bit more and do the measurement again. So it's empirical. Okay. Now we're not in the world of true logic and beautiful, perfect mathematics. Now we've come down to earth, and we're talking about data and how things work. And so we're going to say empirical tests, eta. Right, so that determines how much energy I have, and so on and so forth. Budget cuts and so on. We'll say we'll use this eta and narrow there. That's all there is to it. Okay, so this basic thing is the intuition behind a lot of stuff that we do in machine learning. All right, so here we go. So that's all we need, I think. All right, so let's now put a comment there, and put a comment there. Ian, put a comment there. Put a comment on line 14, put a comment, and in the comment, say, am I there on the screen at all? Oh, I'm actually far away, so I couldn't see me. All right, okay, all right. Comment and the function, make a name takes a name, the function. All right, go ahead, type the function, make a name, the function, make a name. You know, after this is fleshed out, you'll know exactly what to do, I think, without even cutting code. Make a name, and I think what we'll do is turn those, no, leave it there. Turn the spaces into underscores, so that make a name is the name of our function also. Yeah, the function, make underscore a, and then underscore. Someone asked a very good question on the Reddit, and nobody's answered as far as I can tell, is that why do we use functions at all? Why can't we? Oh, I think it was Vivian. Said, you know, I said, why do we, I just, that Schrodinger's cat thing, I just took that code and put it in main and it worked, okay? I don't think anyone's answered, or maybe one answer. Yeah, I think Isidore answered. More people should take a cut at it, okay? It's a great question. It's a great question. And it's a fantastic opportunity for all of you to answer your own, you know, give your own angle on why that is. Because there are a number of reasons, you know, it's usually not one reason most of the time. There's many reasons, and all of them are good reasons. And so we got an opportunity, a right picking field. Everybody take a crack at it and answer that question. All right, okay. The function make a name, and then put, you know, whenever I say function and the name of the function, put open close after it, so that it's very clear we're talking about a function. Yeah, open close, and then no space after that, so that we know make a name is a function. Yeah. No space after make a name. No space after make a name. Yeah, okay. And after that space, inside the parentheses, say string name. Okay, I'll explain this. Okay, so say string name inside of the parentheses there. String name. Okay. Actually, no. Right there. Just say right where you are. We'll elaborate this later. Okay. Make a name. We'll return a changed. We'll accept a name as a parameter and return a changed name. I think that's much better. We'll on the same line too. No, on the same line you can say. Thank you. That was your question. I totally didn't listen to you. The function make a name accepts a name as a parameter. Accepts a name as a parameter. I know ACCEPTS, right? Accepts ACCEPTS. Yeah, you know, your hearing combined with my vision is a bad combination. Okay, because I don't know whether you type the right thing or not. ACCEPT. Okay. Yeah. Accepts, but plural, accepts a name as a parameter, and returns a new funny name, based on it. Okay. Go on to the next line. And returns, plural. Okay. Returns, and then, you know, and break the line after. Yeah, that's fantastic. That's a great place to break the line, I think. Yeah. Name is a parameter. And it's not perimeter, okay? It's a parameter, P-A-R-A. Yeah? Everybody's got to get this right, okay? All of this terminology may seem like dull and boring right now, but it'll save you like tons and tons of time, because you're going to see these words hundreds and hundreds of times, all of the literature. Even you go to Google and type these things in and say, you know, how do I reuse this thing? They'll say, this is how what it is, and these are parameters, okay? Yeah, hey, Raj. Yeah, okay. So we'll get to that. A parameter is something... we'll get to that. Okay, good question. Okay, all right. So and then there's different ways of using parameters too and passing them. We'll get to all of that very soon. Right? Returns a new funny name. That's it. Okay. On the next line, we're going to declare the function. Okay. We say string. Just no comment. String, space, and then say make a name. Yeah. No. So string space make a name. I think let's see if it auto completes. Hey, it's actually picking it up from the comment. Right, and it's auto completing. That's really cool. All right, so and then open parentheses, and then inside there say string name. Okay, now this name is called a parameter to this function. Okay, and what this means is that when this will come in week number 5, I'll have a lot more luxury to talk about this. Okay, and this is a very important concept involving stacks and everything, how function calls work. And I don't think this is even taught in many of the classes, even out there. Okay, and it's like super duper important stuff when it comes to functions. You have to know a little bit of computer architecture, but not a whole deal. You don't have to do CS10 to understand this. Okay, so I'll talk about this. If I don't, remind me in week number 5. Okay, when we actually deal about function, and it's part of the midterm. We'll be doing functions in the midterm. Okay, so but in a nutshell, so far. Okay, so function is when the control the CPU is basically, just imagine one CPU, right? Right now we have multiple threads and many things happening at the same time. Just imagine there's one guy inside, okay, cranking through instructions one at a time in a pipe of instructions, one after another. That is a basic model in the computer architecture. Yeah. Okay. All right. So that's going through say, yeah. Okay. All right. So that is the control. Is the instruction comes into my window. I look at it, interpret it. This is fetch the instruction, interpret what it is, and that'll tell me what to do, right? Maybe that says, go and fetch some bytes from memory, XYZ, right? And I might say, here's 2 places, just add them and put the result somewhere else. That's all, right? So there's a bunch of instructions like that. So that window will tell me what to do. So it'll fetch that, interpret that, and then I'll execute what that told me, okay? And the next thing I'm going to do is push this guy out and push the next guy in. That's all. And then I'm going to repeat that endlessly until I die. Okay, that's all. That is your CPU. That is, that is your CS10 in a nutshell, right? I mean, there's a whole lot of frills around that you learn. But if you don't learn this, then CS10 is going to be a chore. Yeah, you're learning about computer architecture. That essentially is the model we're after. We're looking at the window, Turing machine, right? And essentially, if you learn about Turing machines also, very similar. You look at the window, decide what to do, interpret it, execute the action, push it out, push the next one in. It's incrementing. So now you have control flow going one at a time, right? Functions have this really freaky and cool behavior that is built into the chip, okay? They say you can change the control flow, okay? How cool is that, okay? That is in life. You don't have to go like this. All of a sudden you can branch off, do someone else, live someone else's life, come back and resume from here. How cool is that? Yeah, and that is what you can do with functions. Okay, and it says at this point you call a function. I'll make sure as the God. This operating system is a God of programs. As it says, as a God, I will make sure that right now you'll forget everything about your life and you'll go and live this other life of a person called make a name. Okay, and I'll make believe that everything before is gone from your universe. It doesn't even exist. But when you come back, I'll make you forget that, right? And then you remember everything from here on as though nothing happened. In fact, something like that just happened like 5 seconds ago. You guys are not even aware of that. Yes? Okay. All right. So that could happen. Yes? Like in a story. You just go out, come back. As long as the context is switched, nothing, you don't notice a single thing. Yes? That is what a function call is. Now, certain cool things need to happen at the operating system level in order for that to happen successfully, in order for the illusion to be maintained. Because if the illusion, if the execution of that dance where you disappear and come back and you're oblivious to your disappearance for even, a conscious moment, okay, which may be far less than a second, then the illusion is destroyed. Yes? Okay, so this illusion has got to be so perfect if you're running a simulation. It's got to be so perfect that the chances of failure are so low that you can never suspect the illusion. So anytime you go in, like you can think of this as, in philosophy classes, is, I think when I was a philosophy student, a very, very long time ago, when I was your age, maybe, okay? I think it was my professor actually proposed this as a hypothesis, saying, imagine, his name was Graham Audie, okay? He went on to teach philosophy at the University of Colorado Boulder, okay? And we had very nice discussions, okay? But he actually proposed this as a challenge to the class. And I don't think there were many interesting discussions from the class. But he said, imagine you're going to an operating theater. The surgeon has to, perform this, procedure on you under anesthesia. And imagine that you're just paralyzed, but you're completely conscious. And the entire procedure happens, and there's no visible empirical signs, but you actually go through this painstaking procedure. But however, the anesthetic is designed in such a way that when it wears off, it'll erase the memory of that happening. And you'll come back to a full context of exactly where you were. So you think that you've gone under and come back, but during that time, you actually experience a horrific, surgery happening on you when you were conscious. Okay, so that is an interesting experiment, isn't it? It's a very interesting thought experiment. And that is, and it's so stark as an experiment that, thanks to Graham, really, that I'm actually able to use it here to exactly the same effect that it had on us when we were students. Because it is so stark as an experience for a human being that if you apply it to something that it fits, that experience will always stick to you. And now you know what the hell a function does. Because the operating system as a God will basically say to it, right, go back and do this guy. You're going to do this and come back. And when you're doing this, everything is, as though you're just that. Okay, you think, does it all make sense now? This is what your make name function is. Okay, so here on the next line, all right, so let's put one more comment. Okay, one more comment above, right? Just because Yihan has the puzzle link. No, put the comment above. Put the comment above, because right, yeah, right. This function takes a parameter called name, okay, as a parameter, right? Now, what happens, going back to Raj's question, is a parameter, there's got to be some way in which when the control is transferred, saying, well, right now you got to execute that, make a name code, and it's somewhere else in memory. It's not here. You can't do +1 to go to the next instruction. All of a sudden, you got to go to, XYZ, which is not +1, some random location. So, but if I do that, I can jump. That's one instruction. Okay, I jump to that instruction and say, well, control is transferred. But if I just jump, meaningless jumps, like long jumps without preserving context, it doesn't give you a lot of power. Okay, and you can experiment with that just using go-tos. It just results in a mess in a code, right? The real power of jumping comes when you remember where you jump from, and that you never forget where you came from. And so the operating system makes sure that when you jump when you have the go-to, this is the go-to, the function call is exactly the same as a go-to, except that it has added a value from the operating system that will remember return address. Every time you make a jump, it remembers 16 bytes or 32 bytes or whatever the address space is. It'll remember. All right, when I'm done with the function, even if I've lost all memory of my future life or that that hypothetical illusory life inside of the function, even if I've lost 100% of the memory, I will at least have my return address because that's still on the stack. No, it's not return 0. No, return 0 is different. Return 0 is what we humans do to say, here's a function calling another function. When the function is done, let it give me an integer back, right? And we say return 0, return 1, that's error codes for us. But the communication between the operating system and the chip is different. It says it has its own stack, of inside the operating system saying these are all of my return addresses. So I have a function when I was executing this. So I push my return address here, and I go into that function into a different world. When that world is finished, I forget about the other world, right? Now I'm not lost, however. After I've forgotten about that new world, I'm not lost because I still have my return address. I can go back to the stack. I pop one more thing. That's my return address. I go back to where I was. So isn't that a nice model? Yeah. Now you can do that any number of times until you run out of space to store that thing in your stack, right? And again, that is called a data structure that you will actually implement later on, week 11 of this class, right? It's called a stack. And a stack has this beautiful feature that the last thing that you push into it is the first thing to come out, meaning that it's like a stack of dishes or something, right? You keep on pushing frames into it, right? And you say, well, where do I need to go? It'll say the last one on is the one. So you have function A, function A1, function A2, function A3, and so on, right? This calls that, this calls that, this calls that, and so on and so forth. When some function is finished and says, I got the return address, whose return address does it get? It doesn't get returned to all the way back here. It goes to the immediate previous caller, yes? And so a stack is like beautiful there because every time the system stack, not our stack, right? So it says, every time a function is called, it says, this is the place I need to go back to, and pushes that on stack. It's called return address on stack. That is why in C++, since we just, juice every single drop of juice out of the CPU, CPU programmers have figured out how to get, if you can't get at it through Python or other places, okay? If you're really interested in this thing, you can go to assembler or even C++. Assembler is harder, especially since it keeps changing, but C++ is exactly the same as assembler, almost, because if you can actually go in Xcode or something and say, don't go all the way to machine code, just go to assembler and I can look at the code, and you can go to Google and say, what is the instruction set for ARM? And I'll just give it to you. And you can compare and know, yeah, this is the translation, right? So you can actually, it's very, so if you want to extract every single bit out of it, it's really cool. So anyway, I was going with that. Yeah. So it gives you that, it pushes all the return addresses. And then it'll say, how about if I need some stuff, so let's say my kid is moving to San Diego, right? And I let him go there. And I say, well, I'm going to set him up with some stuff too, right? Go there, but also, I'll give you a pantry of some, some stuff, cereal and bread, okay? So not only do I, change the return address, saying this is return address, but I set up a new frame. That's called a stack frame, right? Set up a new frame. This is your new world now. Don't think about home, right? You're not a kid anymore. right? You got your own, you got to learn to live on your own. So it's a new world, which means you got to completely forget about it. But when you forget about it, this is not lost. It's still there because there's a return address, right? Anytime you feel completely lost in your life, you look at the return address and that'll tell you how to get back home. Okay. But right now, imagine the return address doesn't exist because that'll interfere with, knowing this new world. So that is the kind of message you're getting through, and say, this is your new world, and it goes there. And I'm going to set it up for you also. I'm not just going to give you a blank slate and say you're on your own. I'm going to go and get your cereal and bread and milk. Okay. So those are the parameters. Okay. I say, I'm going to give you cereal, bread, and milk, but you're going to turn that into knowledge and give it back to me. Right. That is my function call for when I send my kids to a university. Right. So, so I'm going to feed in the parameters of sustenance and get out the output of knowledge. And that is your function call. Right. So you're going to give it a name, and you're going to change the name into something interesting. Right. Just like knowledge turns the whole world interesting. Yes. Because otherwise, without knowledge, the world is just routine and boring. There's no patterns. Right. But with knowledge, you learn to see patterns in the world. Say, hey, even if you whether agree or disagree or something, the pattern itself has aesthetic value because you see that recurring many times. And you tend to associate with that, and it looks like a musical note, right? So you get into the rhythm of things, all right? I think that's what people call it, right? Getting into the flow of things. And that only happens with age, I think. I don't think young people should basically force themselves into it. I think young people should just basically live life, but not a constrained life, but so that you get many, many different experiences. And it's important to get lots of experiences, because only when you get lots of experience, you can factor out, right? If I just give you two polynomials and say, what is common? Yeah, right? So you get lots and lots of polynomials, and factoring is also a fun job. So you say, what is common between all of those things? So, and then, you can also enthuse yourself into, that's why, don't hurry. Because I see a lot of young kids, especially here in Foothill, right? A couple of years ago, maybe, 5 years ago, I ran this boot camp here. Not a boot camp. This is a meditation, or, what was it called? Mindful meditation camp or something like that. Some students liked it, right? So Parker emails me even now saying, give me a video or something like that. But really, it's really silly, because a lot of students, said, well, I'm stressed at Foothill, I'm doing all these courses and so on and so forth. So, all right, let's do mindful meditation. Come at, 7 a.m. lecture or 8 a.m. lecture, come at 7 a.m., right? I'm going to make you all sit down and, do meditation and shit like that. It was kind of boring. It was fun. It was fun for students, the ones who showed up. It was cold and all. But, that was not the right approach. Actually, when I think about it, as students at your age, you should not do 20 units and then do meditation to cool down, right? Just don't do 20 units. You'll automatically, your nature is to be cool. Your nature is to just follow inquisitive, cool, interesting things. Now, if you just, do 20 units of hard stuff, then you're saying, oh, now I need to somehow nurture my nature, right? But nature doesn't need nurture, really. It'll just grow by itself if you don't, stamp on it. But I think what we're doing is just what we're doing to the nature itself, saying, we want to reduce greenhouse gases. I don't know, maybe it's not true at all, right? I'm just, spouting out the top of my head here. We want to have all these incredible technologies, reduce greenhouse gases, right? We say, no, just reduce resource usage a little bit. We won't have greenhouse gases in the first place. We're going to have to create the problem and then solve it, right? So in computer science, I think, that is what we try and do most of the time. We say, don't create the problem in the first place. And that is what you'll see in a lot of expert programmers, okay? It's a lot of people tend to think that expert programmers are those who know the solutions to lots and lots of different kinds of problems, okay? What I found, Brian, I'll get you in a sec, right? Brian, yes? Yeah, I'll get you in a sec, okay? I saw your hand up. I'll get you in a second. So a lot of people think that expert programmers are those, you show them any problem they'll know to solve. But really, I find in my experience anyway, expert programmers are those who know how to stay away from hard problems. Okay, so they just know, they can recognize. They've come across so many problems that they can recognize a hard problem when they see it. Right, like just when you see people, that person is, don't stay away from that person. Yes, you have that instinctive feeling sometimes. Maybe it's wrong, but with the age, you get better and better at it. And say, if you want to have a good, productive, happy life, you just have to stay away from some people. Brian, are you on camera, by the way? Because the online students won't. Yeah. Okay. There you are. There you are. You can face the camera. Actually, I'll look at this. Oh my gosh! All right. Thank you. All right. I didn't realize we only have 10 minutes left. Okay. All right. Here's the deal. Okay. We'll finish this today in 10 minutes. And anybody who wants to do the gradient descent, simple project, like, half-hour project, okay? I promise half-hour, okay? With Zoom, over Zoom, over the next couple of days, simple project, we'll just do online GDB, right? It's a simple project. It'll just be C++ practice for you. Pick a convenient time over any time from today to the next class, but make sure you're done with the quests and all, right? Quest 1 and 2, and say, well, can we have a 1-hour class? Go over another C++ problem, maybe gradient present, because there's a bunch of us interested in AI and machine learning. We want to do, do machine learning 101 before we actually enroll in our, college. Yeah. So you can do that too. I'll just walk you through the code just like this. All right. We're going to finish this now. Thank you. All right. So this function takes
Professor?
a parameter, called name. Hey, Yiheng. All right. Now we're back. All right. Well, I'll finish the code now. Right. And now yank me back. Anytime I'm distracted, yank me back. Okay. All right. This function takes a parameter called name on the comment on line 17. Yeah. All right. Called past tense. Okay. Name and returns a string and name and returns. And on the next line you can say, all right, yeah, okay, returns a string. All right, returns a string. I think that's finished. That's nice. No, that's nice. That's good. What you had is good, right? That's all we need. Okay, so we're going to say right now after the closing parentheses, put curly brace. Yeah, all right, and at the end on line 20 put, all right, okay, that is a function that is complete, but it is returning, it should return a string. That is what you have up there is a signature of the function. It's a string something. Yes, that means that function has type string. That means when you call that function, it's going to give you a string that returns a string object. Yes, okay, all right. So in order to make the compiler happy, even though we're not going to implement the logic of the function, we're going to say, hey Brian, were you in my 2B or something like that last class? Hey, there was a Brian Lee in my class and he said, in fact, on Reddit, go to the Reddit, 2B Reddit, there was a Brian Lee, I think. No, he did my 2B. And he said, well, this looks like fun. It looks like fun. I want to do 2A now, right? And he said he was going to enroll in my face-to-face class. So I thought maybe that was you. That was you? No, it wasn't. It was you. Are you in Tesla? You work at Tesla? Oh, so you are the Brian Lee. Oh, wow. You look like totally different on the video, on the 2B videos.
I think it might be a different Brian, actually.
But you do work at Tesla.
Yeah, how do you know?
Because that Brian Lee works at Tesla too. This is this conversation is turning out to be much more interesting than the class. It's like X-Files, Mulder and Scully talking here. All right. So you are a Brian Lee who works at Tesla, and you're enrolled in this class. And there is another Brian Lee who was in my CS2B. And in fact, Foothill won't even let you enroll in 2A if you did my 2B, because it'll say, hey, you already did 2B, you can't fleece the government again. Yes. So you have to be a different Brian Lee. Yeah. Okay, but that guy enrolled in my 2B, and he was a Tesla engineer, and he said, this looks like fun. I'm going to enroll in 2A because the face-to-face class looks like even more fun. Okay, so he said that on CS2B, the green subreddit. You can go there and look at it. His name is Brian Lee. Okay, all right. So even now, if we had time, maybe Ian could take a look at it. But we'll finish this program. Okay, we're going to do a stub. Okay, put a comment there. Put a comment there. Yeah, put a comment inside the function. Okay. And say space, and say return a dummy string called dummy. Okay, return a dummy string called dummy for now. Right, return a dummy string, dummy, D-U-M-M-Y, dummy string called dummy. Right, for now. And on the very next line, you just say return dummy, right? On the very next line, you say return dummy and then a semicolon after that. That'll keep the compiler happy when you compile, okay? It's a useful skill to have. When you do questing, do all the functions, empty functions, and say, just return whatever the hell it's supposed to return. Like if it's a string, return empty string or dummy, right? Boolean, return true or false. You just know what to return and return that, okay? No, return dummy within quotes, and it's not a function, okay? Return dummy, the string dummy, right? Return within double quotes, you say dummy within string, within double quotes. No, within double quotes. These are all syntax you got to get used to, okay? It's the first time in C++ you're going to be doing this kind of thing, okay? Within double quotes. Yeah, you say dummy. Okay, so just shows me that you don't have enough practice. Okay, it's only week 2 or something. You just need more practice. Everybody needs more practice, not just Ian. Okay, everybody just need, and even if you know what to do, that is a danger. If you know what to do, you think, all right, well, I just need understanding. No, if you, after you know what to do, keep doing different kinds of the same thing. Okay, it just need to be practiced. Okay, semicolon after that, semicolon, semicolon, semicolon. No, semicolon, semicolon. Semicolon is what tells the compiler. Oh, I see. Yeah, you got that? All right, get rid of the blank line. Get rid of the blank line. Get rid of it. Get rid of it. That's our function for now. All right, you're going to change it. In fact, put a comment after after line 17. Hit enter after line 17. Oh yeah, all right, yeah, put a comment there. Put a comment there. Right, and say to do, TODO colon, TODO, and then colon. All right, this is what everybody has to do. Right, change this function to do interesting things and return something more interesting. Change this function to return something more interesting than dummy. And then on the next line, you can say comment, hint, use for loops, and so on. Ask in the forums for ideas. Okay. All right. So that is the best way to do it. Everybody's going to look in the forums. Try and do this. If they're stuck, they're going to ask in the forums. I'm trying to change this function. Do you have any ideas? And maybe Jonah will say, all right, I already tried changing everything to vowels. Maybe you can try something where you change every third letter to X. Yeah.
Sorry. So to change this function.
In your own way and share. Change this function to return more interesting things, to return more interesting things than the string dummy, right? Than the string dummy. Oh, cool. Yeah, Pani has actually shared something online GDB. Someone actually did a gradient descent in class and shared the link, right? But we won't go to that link. We'll just do it on ourselves. I think that'll be easier. All right. Okay. All right. So that's what students have to do, and they're going to share these links. Right now, let's go to line 23. Hit enter and do our main. Okay. Enter main. Now I'm just going to call off the code because this is all standard stuff that we've done. No, nothing to do with functions. Just going to type it. Okay. Ian, I'm just whatever I call, just type it. Okay. For now, it's all very straightforward. Okay. So enter, but put a blank line between different functions. So after the curly brace, blank line. Yeah. All right. Say int space main. All right, main, int space main, open, close, and no space between the main and the open, close. All right, and then space, and then a curly brace, space, curly brace. Right, enter. Okay, that's the body of our function. And main has got to return an integer. So let's just say return 0 at the end so that we just have our template. Yeah? Yeah, return 0 at the end. So that's a compiling program. In fact, if you run it now, it'll just, no, put a semicolon. Everything you do, you get in the habit, okay? Especially Python programmers. Do you have a semicolon in Python? No. Right. So yeah. All right. So anyway, if you are accustomed to that, you forget that. Because many times when I get 2A students typing, they forget that, and they're Python guys. All right. If you compile this and run it, it should run without any problems. Hit the red button.
Do I need to put include IO string?
No. Good question. Yeah. Hey, actually, good question, Ian, and a fantastic answer, Roger. Okay. All right. So Ian asked, should I put a semicolon after the IO stream? And Roger said, why don't you run it and find out? Okay. So fantastic. Okay. I couldn't have done, much better than that. So thank you all so much for, Yeah. Okay. So it says that it's, the compiler language is different from the C++ language. Okay. C++ requires compiler, semicolons, but this is a compiler directive, right? It doesn't require semicolons. All right. Now it runs without any problems. Yes. Okay. Now let's print a prompt. Yeah. Programmed exit code 0. In fact, if you change your return 0 to return, 57, it'll say exit code 57. Try that experiment. Change the 0, return 0 to return 57. You change the return 0 to return 57. Yeah, anything you want, any number you want. Yeah, run it. It'll say program exited with exit code 57. And that is a really cool way for if you don't want to use semaphores and complex ways of talking from one program to another. If you can afford to wait for a program to finish before you do your own work, lots of good engineers use just signaling through exit codes. So you say, if I exit with the exit code 57, I know that this failed in this way. I got to change it. All right. All right, good. All right. So, all right, change that to return 0. and then we're going to do a couple of comments. Just bear with me. We're not going to flesh out the comments, right? We just do comments, and you guys are going to just see out and read in and so on. Okay, that's what we're going to put in the comments. All right, put forward slashes for the comments. Forward slashes for the comments. Oh, right there where you are. Yeah, space. And say print a prompt asking the user what the name is. Yeah, print prompt, and everybody should know how to do that. If you don't, ask in the forums, and we'll tell you how to do it. Yeah, okay. And then two enters. Print prompt asking the user what their name is. Now I had very name is okay. Enter. All right, enter. All right, and then one more comment. They're all to-dos, okay? You can actually say one dot print prompt, okay? So you can actually number them, so everybody will know. That's things they got to do. One dot, yeah. All right, two, right? Two. Read in their name. Read in their name into a string variable. Okay, read in their name into a string variable. Name. Read in the name singular name into a string variable. It's just comments, okay? Just 2 more minutes. Juno, I know you're putting your laptop away and all. It's okay. Put stuff away. You know, it's okay. You know, Simon also. But 2 minutes. Just bear with me, okay? Don't leave. Read in the name into a string variable. Which means you got to create the string variable and all. Okay, everybody got to know how to create a string variable and right. All right. Now enter. Right, number three, comment number 3. 3, yeah, 3. Read in. All right, now call the function make a name. Call your function make a name, which hopefully does something interesting by now. Okay, you can actually say that because you know that's a reminder for people to go and change that name. Make a name. And then open close because it's a function, open close, and space, which hopefully does something interesting, more interesting, right? Which hopefully does something more interesting now, something more interesting by now. The next line, does something interesting by now. We know it does something, right? It's something interesting by now. You can go to the next line there because you see that thin vertical line, thin gray line, that is 80 columns. So always try and keep. Yeah, but that's maybe too short, but that's okay. Right. Yeah, which hopefully does something interesting by now. Something more interesting by now, right? Something more interesting. So, all right. Good. All right. So on the next line, you're going to say, some people have to catch buses and all. Okay. All right. So if you have to go, please, go. Don't worry. We'll just complete it, and then Ian will share the link, the online GDB link. Okay. All right. So if you have to go and catch a bus, feel free, but we'll complete it and share the link. Okay. Which hopefully does something interesting by now. All right. So and then on the next line, enter. Number 4, you're going to say use Erica Altamirano's hack to inject suspense. Look at the video. Look at the link shared by by Krishav Gandhi. I think that's his name. Yeah. Right. Look at the link shared by Krishav Gandhi to find the hack by Erica Marano. How to implement. Right. Oh, you're not typing. Yeah. 4.
Oh, you mean comment 4?
Yeah, comment 4. These are things you got to do. 4. Right. Look at the link shared by Krishav Gandhi. All right. And to learn about the hack for suspense. About the hack for suspense. Yeah, about the hack for suspense. We've already credited her. Yeah. Okay. To learn about the hack for suspense and implement that. Okay. And implement that. And I think everything else is in that code. It calls that function and it returns a new name. And then all it does, it says, hello, wait for a little while, wait a bit more, wait for a little while, wait a bit more, wait for a little while. Each one is a sleep command, right? And that is just 5 lines, okay? And if you don't understand anything here, ask. Put a comment, all right? Put a comment there. If you don't understand anything, ask in the forums and people will jump in to help you.
Yeah, I mean, look at the link shared.
Oh, I see. Learn about the hack. Learn about the share. Link at the shared by Krishav. Krishav. Yeah, Krishav Gandhi. That's his last name. Krishav. Krishav. Space Gandhi. Gandhai. No, Gandhai. You know, it's a common misspelling. Is it Gandhi? No, Gandhi. No AI. It's just yeah. All right. That's his name. If you look for his post, you'll find it. That's what you got is right. Okay. To learn about the hack for suspense and implement it. Okay. On the next line, you can go. No, go on the next line and say for suspense and then implement it. Okay. For suspense. Yeah. All right. Okay. To learn about the hack for suspense, not suspenseful, suspense, and implement it. Okay. And implement it. And then you can add a comment saying if you have any questions, ask in the forums and someone will jump in and help you. Okay. That's all. And we'll, continue the rest of it. Is this fair? No, what Ian is going to do, thank you for Panani for reminding me. All right. Okay, there is a link. All right, there's orange link. Share. If you have any questions, go to our Reddit and ask questions. Go to our Reddit and ask a question and someone will help you immediately. Okay, which is probably the next day or something. Yeah.
Are these comments just going to serve as the skeleton? You just want
yes, it's just a skeleton and you just take a fork of this code and then you can change it. And then you have your own version. Because I think this site will, when you click that, there's a button. There's a button for fork. Okay. Yeah. If you fork it, it'll give your own copy. You can change it. Okay. Is everybody okay, Charlie? All of you guys online? Everybody okay? Benjamin, you good? Yeah. Okay. Hey, it's really cool. Coincidence, Bench. Brian. Okay. Yeah. Okay. All right, cool. All right, I'll talk to you guys later online. I'll end this. Then it'll stop the recording. Oh no, he'll just share it on the Reddit, but you can share it here too. Hey, go click share. Otherwise, if I click this, I have to do it. I have to do the share. No, he has to. Hey, click that orange thing or click the orange. No, click the orange thing. Okay, that link there. You see that link? The share code.
Which one?
No, share the top one. Yeah, triple click there, and you have to share that on Reddit, saying this is the code we worked on. That one, yeah. You got to put that in your clipboard. Put that in your clipboard, and then on the subreddit, you share it saying this is a code we worked on. Have fun with this, guys. Okay, that's all. Yeah, don't lose that. Okay, if you're in a clipboard and you just reboot your computer, it's gone. Share it before you forget. Everybody okay? Or share it on the Reddit.
Professor?
You have an account on Reddit?
Yes.
Yeah, where would we find the Reddit link?
Oh, just go to Reddit and go to our CS2A.
Okay.
Our CS2A. It's in the syllabus. This links all over the place. I see you later, Brian. We'll talk later. Look in the Reddit. Look in the Reddit.
And Professor?
This is really cool. A very interesting coincidence. Is this okay? Can I close the meeting now? Can I shut the meeting now?
Professor, can you hear me?
What's up? Hey, I can hear you. Hey, Ben, you got a question?
Are we allowed to use helper functions and
Don't
in the
try
overall
not
functions?
to unless it says you got to use an X helper here. Don't try to just use it in code. But I know Vivian asked a question. How Schrodinger cat should it be a function? If it says use a function, use a function. Yeah. Otherwise, if you can do it in code that's inline, that's fine.
Okay.
One of the functions I already kind of submitted with the helper function. Should I redo that? Or
if you have your own helper function, that's okay. Yeah. Yeah.
Okay.
Yeah, I was thinking that I use a string.find or something like that.
I see.
No. Right. If you want to write your own helper functions, go. By all means, go ahead.
Should I include that in the header file as well?
You mean a function in a header file? Oh, you have to include the So here. There is a detail where to declare the functions. Is that your question? Where to declare the helper functions? Yeah, just declare them. Before you use them, the compiler needs to see it. That's all. It needs to see the signature of the function before you use it the very first time. So put it in a header file if you need, or group them all together and put in a comment in one source file, whatever it is, right? Some structure will emerge eventually. Yeah?
Okay, sounds great. Thank you.
All right, cool.
Where would I access, just for future reference, where would I access the homework assignments? Would they always all be on the calendar? Because I can see some there. But...
No, calendar is buggy. Okay.
Is it
just ask in the subreddit and someone will help you out. Okay.
Okay. And what is the subreddit?
Great. Thank you, Ian. All right.
Is it
I'm going to end the meeting. Is that okay?
All right. Yeah, I'm gonna head out. See you.
Right. Hey, have a good day. Good
you too.
night. Bye. See you. Talk to you later. Bye.